Hello. Hopefully, hold on, let me test something. Okay, I think it's working. Okay, welcome. I'm going to make a quick video about the PQ method. We don't have my smartboard working today, but we're going to do what we can with the Blackboard. So here's the problem I want to do. We want to factor 2x cubed plus 3x squared minus 11x plus 3. We want to use the PQ method. Or sometimes it's called the rational roots method. And here's how this works. So we're first going to come up with some potential solutions. We'll hopefully find at least one solution that works. We're going to use long division or synthetic division, and I'm actually going to use synthetic division this time to figure out what happens when you divide that factor away. And so you divide that factor away, and then if you can, you factor the rest. And actually, in this case, we're not going to be able to, as we'll see, but we'll give it a try, even if we can't. And if you can't factor the rest, then you're just done with what you have at that point. So here we go. What are the potential factors of this? Well, the numbers you look at are P and Q. Sorry, P is over here, Q is over here. And your potential rational roots P over Q are things that divide into P and things that divide into Q. So for example, the first one that we always start with is 1 over 1, because 1 goes into 3 and 1 goes into 2. So there you go. And then you get all sorts of other combinations, like 3 goes into P, 1 goes into Q, 1 goes into P, 2 goes into Q, and 3 and 2. And you get plus or minus all of those. With this polynomial, these are all the possible rational roots. The next step is to figure out which ones work. And to do that is simple in theory, although very time-consuming in practice. You have to plug these values in to your original polynomial. So for example, you might start by plugging in, well, I'd always start with 1. So let's just plug in 1. So we're going to do f of 1. So this means to plug 1 into the polynomial. It's going to be 2, 1 cubed plus 3, 1 squared minus 11 times 1 plus 3. So to work that out, that's going to be 2 plus 3 minus 11 plus 3. And that is not equal to 0. It's actually equal to, what would that be? Negative 4. Not equal to 0. That's all we care about, whether it's 0 or not. In this case, it's not equal to 0. So that didn't work. And there's actually 8 possibilities to try. And you can imagine that triangle 8 is kind of time consuming. So here's what I'd recommend. Let me share my screen here. So let's look at Desmos. So this is desmos.com. If you just hit graphing calculator, I opened up Desmos. Do projector mode. And here's what you can type in. You can type in your original polynomial, which is 2x cubed. You can even do this on a phone, and it works just fine. There's a little keyboard to type this stuff in. 2x cubed plus 3x squared minus 11x plus 3. And now you can actually see on the graph where the zeros or the roots are, but just to illustrate, let's type some things in. So if we type in 1, oops, let me call that something, sorry. So in order to type something into this easily, it helps to actually call it something. So now we can see that f of 1 is equal to -3, just like I said it was -4. I guess I did that wrong, sorry. It's -3. That's what we should have gotten before. Anyway, non-zero. And here you can just try everything really fast, like -1. What else do we got? We got 1/2. That doesn't work. You're looking for something that equals 0. 3/2 is 1. Oh, there we go. We got something that equals 0. It was this one, the positive 3/2. Okay, so that's actually all we need Desmos for this problem. Although Desmos is going to be very helpful in this class. Okay, so I'm going to stop my screen share. So now we found a solution. We found that 3/2 works. So what do you do at this point? Well, what you want to do is you want to take your original polynomial and you want to divide out by the factor corresponding to 3/2. So let me show you what this would look like with long division, but I'm actually not going to do the long division. I want to do synthetic division with this one. So basically we want to divide out the x minus 3/2. I'm just going to put 1.5. So this was the root that we found, the 3/2. We want to divide this into 2x cubed plus 3x squared minus 11x plus 3. And that way we will basically figure out what's left after you divide this out. That's going to be part of the factor process. Now, instead of doing this with long division, you can set a synthetic division. So you can flip the sign on this, make this a 1.5, and put in 2, 3, -11, and 3. And you can just kind of do this kind of nifty thing where you bring down the 2, and then you multiply by what value is here. So in this case, it's 1.5. 2 times 1.5 is 3. And then you add down. 3 plus 3 is 6. 6 times 1.5 is 9. -11 plus 9 is -2. And -2 times 1.5 is -3. And you can see we get a remainder of 0. That's what you want. You really want a remainder of 0 when you do this TQ method. So now what we've done is we divide out this x minus 1.5 factor. So here's what we have. Let me come over here. We have the x minus 1.5 factor. And the rest is 2x squared. So I'm just taking these coefficients. 2x squared plus 6x minus 2. So this is what we have so far. This is basically, what we've done one iteration of the PQ method. Now the only thing left to do is to see if you can factor it more. And in this case, well, I said this is not going to be able to factor, but there's something you can do. Notice there's a 2 that goes into each coefficient. So you can bring in a 2. So if I bring out that 2, I'm going to divide each of these by 2 and make it x squared plus 3x minus 1. So now we have this. And, you could leave it like this because x squared plus 3x, well, let me back up. The next thing to do would be to try to factor this. X squared plus 3x minus 1. And if you remember how we do that, for something like this, you can just, you're looking for 2 numbers that multiply to -1 and add to 3. But there's no numbers that multiply to -1 and add to 3, so this does not factor. So that's what I was referring to at the beginning of the video. This does not factor. A lot of times it will, but in this case it doesn't. So you could just leave your answer like this. I think this would be fine. What I'm going to do actually though is I'm going to multiply this 2 in here as kind of a sneaky way to get rid of this decimal. So we have all whole numbers. So this becomes actually 2x minus 3. Aha, and there you can see the 3 halves that we got as our first factor. And x squared plus 3x minus 1. And again, because this doesn't factor, that's our final answer. Okay, thank you very much.